So today we are solving a very interesting problem and a practical problem. 198 house robber. And the problem says you are a professional robber planning to rob houses along a street. Each house has certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses has security systems connected and it will automatically contact police if two adjacent houses were broken into the same night. Given an integer array nums representing the amount of money of each house, represent the maximum amount of money you can rob tonight without alerting the police. And the constraints are nums dot length is between 1 to 100 and nums dot I, which means the loot value is from 0 to 100. Okay, so by reading the problem, I can observe one thing, that it's a problem where we have to maximize the amount of money that we can rob. So I will say that let f of I be the maximum amount that we can get up till the ith house we loot. So the ways of reaching ith house as per the problem is we can reach this house from two paths. If we choose to pick if we choose to pick the house just before this, then so this is our skipped path. So if we have skipped this house I minus 1, then we can pick ith house, and if we have picked this house, then we will be coming from the house of I minus 2. So what does this do? So when we are coming from I minus 2, we have all the loot from the houses till we are reaching here. So that would be h of I, and so this, what does this does is this models down to if I'm at I, meaning this is nums of I minus 1, and this is f of I minus 2, and this is f of I minus 1. And when I'm starting from the very start, so when let's say I don't have any house, I is 0, then my loot amount is also 0. And when I is 1, that is all, I have only one house, then the loot amount is just nums of 0. And if I is 2, then f of 2 is basically the maximum of two values that I have in my nums array. So there is nums of 0 and 1 because I can only choose one, so I will choose the maximum of one. So this way I will start building my problem, and I want to reach to the top. So these are the problem definitions, and if I write it up more precisely, so if the last case that we want in this is our I, and these are the cases, and the last case is the generic case, which we want is basically when I is greater than 2 but is less than n or equals to. In that case my f of I is the maximum of either two values, that f of I minus 1 or f of I minus 2 plus the house that I'm going, the house till which I have the loop from the previous. So these are the general cases, and now let's write these down into our problem and how we'll solve this problem. So we say that n is our length of the total nums array that we have, and if we don't have any house, then we'll immediately return 0 in this case, and if there is any one house, then we want to return that value, so we'll return nums of 0. And when my I is greater than 2, so when we have more than two houses, then I want to define two states. So this is for I specifically greater than equals to I greater than 2. So I will define two states, that first is 0 and the first and F1. So if I have 0 house, then 0, and if I have one house, then it is nums of 0. And I will start filling this decision tree from bottom to up, and by up means I mean like we have to find the value of ith house, that if we reach the top ith house in the order, we want to have the maximum loot in that way. So that's going to be, so I will travel from 2 to up to n plus 1 because we have n houses in total, and to include that we will do n plus 1, and we will calculate the loot for the current house. For that we need the previous house, previous two houses and their loots. So that is nums of I minus 1 from where I'm coming, and we'll add this value into the variables that we are traversing with. So that would be these, and in the end we'll return the maximum load that we have found so far, and this will do the job. And now let's run our problem to see how it performs. Okay, let's run it for different test cases. Okay, and now let's submit our solution and see how it does. So it has been accepted and it's running pretty fast. So that's the way of solving this problem. I hope you liked my solution, and if you have liked my solution, then please like and subscribe to the channel. It helps me in creating more awesome content for you guys. And let me know if you have any particular problem in mind that you want me to solve. I can definitely have a look on that. And the time complexity for this problem is, since it's a DP and we are making a choice every time as we are traversing, so the time complexity would be O of 2 raised to n, because we are making two choices at every time, and with that we have reduced from 2 raised to n to O of n, because now we are traversing the whole list in just one loop via this DP that we have maintained. So initially it was 2 raised to n because we are making two choices every time, that we have reduced from O of 2 raised to n to O of n, and the space complexity is O of 1 because we are not using any array to store these value we are traversing and calculating the values of fi as we are traversing the array. So that's how you solve this problem. Thank you.